Hello, my dear students. Welcome to my channel Physics by MKR. Today, I want to give you some tips to understand physics by easy methods. In any chapter of physics, we come across the relation between physical quantities in 5 ways. And the first one is two physical quantities may be directly proportional. Second, may be directly related. Third, the two quantities may be inversely proportional. Fourth one is may be inversely related. And the last one is the two quantities may be independent of each other. So, among these 5 relations, which relation is suitable for a particular situation? That is the way of understanding. For example, let us take direct proportionality between two physical quantities. In kinematics, for a body moving along a straight line with uniform acceleration, the instantaneous velocity v is equal to a multiplied with the t, where a is acceleration and t is time. And this is for a body started from rest. That means its initial velocity is 0. Now the two variable physical quantities here are velocity and time. Because acceleration is uniform, it is a constant. Sometimes it may be constant of proportionality. That's why I say velocity is directly proportional to time. That means if time is doubled, velocity is also doubled. If time is tripled, velocity is tripled. If time is halved, velocity is also halved. So that is the direct proportionality between velocity and time. The second relation is direct. Two physical quantities directly related, but not directly proportional. For example, if the body possesses initial velocity u, the instantaneous velocity v is equal to u plus at. In this equation, initial velocity u and acceleration a are constants for this motion. And the variables are velocity and time. If time is doubled, instantaneous velocity is not doubled. But no doubt, as t increases, velocity also increases. As t decreases, velocity also decreases, but not same number of times. For example, let us have an numerical value. Initial velocity is 10 meter per second. Acceleration is 2 meter per second square. And after 2 seconds from count, the velocity, instantaneous velocity v1 is equal to 10 plus 2 into 2, which is 14 meter per second. Suppose if I double the time, if time is doubled, the instantaneous velocity becomes 10 plus 2 into 4 is equal to 18, and the ratio v2 by v1 is not equal to 2 but greater than 1. That means when time is doubled, this velocity is not doubled but no doubt increases. So this is the situation where two quantities are directly related but not directly proportional. But this is one of the examples. There are so many such examples in different forms. I am giving one example for this. So basically, directly proportional and directly related are not similar. They are slightly different. But the sense is, if one physical quantity increases, the other also increases, and the other, when one physical quantity decreases, the other also decreases. In direct proportionality, the number of times are same, and in direct relation, the number of times are not same. Another example for directly related equation. For example, y is equal to bx square. Here, b is a constant, y and x are variable physical quantities, and y is directly related to x. How? If x is doubled, y becomes 4 times, not 2 times. If when y is doubled, if x is also doubled, then we say x and y are directly proportional. But here, when x is doubled, y is quadrupled. That means becomes 4 times. So number of times are not equal. That's why y and x are directly related. For example, if x becomes 1/3, y becomes 1 by 9 times. That means here also, when x decreases, y also decreases, but the number of times are not same. So this is how the quantities are directly related, but not directly proportional. And the third one is two physical quantities which are inversely proportional to each other. Inversely proportional. For example, y is inversely proportional to x. That is, y proportional to 1 by x. And in equation, we put some constant, y is equal to k by x. Or x into y is a constant. Or y2 by y1, the ratio is x1 by x2. Here 2 by 1, that is 1 by 2. That is the significance of inverse proportionality from directly proportional thing. Or you can also express x1 y1 is equal to x2 y2. So, regarding the magnitude of a physical quantity, we measure the magnitude as the product of number and unit. In any system, the magnitude remains same, but number and unit change in inverse proportion. Another example for inverse proportionality. The magnitude of any physical quantity is expressed as the product of a number and a unit in a given system. That is, magnitude P is equal to number into unit is equal to symbolic N into U. The magnitude is constant in any system. For a given quantity, for a given measurement, magnitude is constant in whatever system you measure. So P is magnitude, it is constant in any system. That's why number and unit are inversely proportional if you express the magnitude in two different systems. For example, the length of a stick is 200 centimeter when measured in serious units. But when measured in SI units, it is 2 meter. But in both the systems, the same quantity is measured whose magnitude is same. That's why P is equal to 200 centimeter in series system is equal to 2 meter in SI system, which is nothing but N1 U1 is equal to N2 U2. If unit becomes 100 times, number becomes 1 by 100th. In this above case, that is, U2 by U1 is meter by centimeter, which is 100, and N2 2 by n1 is 2 by 200, that is 1 by 100. So this is the way how quantities which are inversely proportional related. The fourth relation is inversely related. That is, physical quantity y is inversely proportional to 1 by x square. That means y and x are not inversely proportional, they are inversely related. But y and x square are inversely proportional. That means if x is doubled, y becomes 1/4, not becomes halved. Similarly, if y is halved, x becomes 4 times. That means when one quantity decreases, the other increases, but not by same number of times. Then we say that those quantities are said to be in inversely relation, not inverse proportion. And the fifth one is y is independent of x. That means there is no relation between y and x. If y changes, x does not change. If y is doubled, x remains same. If y is tripled, x remains same. That means there is no relation between x and y. And for example, in the equation v is equal to at, velocity v is equal to acceleration into time. Here acceleration is uniform, that means a constant. When time is doubled, velocity is doubled. That means v and t are directly proportional. But even when time is doubled, the acceleration remains constant. That means there is no relation between a and t. This is independent of each other. So, altogether, there are 5 relations: direct proportional, directly related, inversely proportional, inversely related, and independent of each other. The entire physics comes under these 5 relations only. But in the case of inverse relation and direct relation, there are so many equations, not single equation. Some constants are involved. So we will discuss them independently when the situation arises. But you have to view while studying in what way the physical quantities are related among these 5 things. And depending upon them, we can develop graphs between these variables. Thank you for watching my videos and give proper comments